Welcome to Chapter 2. We're going to begin pretty simply by talking about a bunch of vocabulary for this chapter. Now, these words are really important. I'm going to refer to them a lot throughout the next lessons and throughout the next few chapters, actually. Now, there's a lot of vocabulary here in this list. I'm just going to highlight and give examples of the most important ones. The first important one is a coefficient. A coefficient is a number in front of a letter, essentially. So if I had something like negative 7x squared, negative 7 would be the coefficient, the number in front of the letter. Now, sometimes, excuse me, we have letters that are all by themselves. So let's say I have something like this. That 9 is a number that's all by itself. It doesn't have a letter. That's a constant. A number without a letter. Anytime you have a number, has no letter with it, that's called a constant term. This next one is extremely important. I'm going to come back to it again and again and again, is degree. Now let's say I write out a polynomial, which we'll define in just a minute. So like negative 7x plus 5x squared minus 13 plus, let's do 2x cubed. The degree of this polynomial is the greatest exponent. So right there, if I look through this polynomial, I look at all the different exponents. So I have a 1 there. If there's no exponent written, it's a secret 1. So that would be an exponent 1. Exponent 2. This one has no exponent, 0. And exponent 3. The greatest exponent is a 3. So we would say this is a degree 3 polynomial. Next, descending order. This is called a math convention, meaning it's something that if you're super picky you should do. Why? No one really knows. We just said a rule forever ago, this is how you should do it. So a bunch of mathematicians said, you know what, let's write polynomials in descending order, meaning we take the exponent from greatest to least. So if I took that one from before, the biggest exponent was the 2x cubed. So that one's going to go first. The next one is the 5x squared. So that one's going to go second. Then I have the negative 7x. So that would go third. And then the negative 13. So I take the exponents and I write them in descending order. 3, 2, secret 1, none. That's descending order. Always get in the habit of writing your polynomials in descending order from greatest to least. The next big one you need to know is a factor. Now the importance for this one is you have standard form and factored form. Standard form, let's do an example you might remember from last year, would be all multiplied out, something like that. That's written in standard form. Now, if you were to factor this, it would end up factoring like this. If you don't remember how to factor, don't worry. We'll cover that the next 2 days of class. We'll do lots of factoring. When we factor it out, that gives us factored form. Now, each form has its benefits. In standard form, it's really easy to find the degree, like we did here. So this would be a degree 2 polynomial. Factored form, can't find the degree. Needs to be in standard form. And then we'll talk about in 2.4, one of the benefits of writing it in factored form. So those are our 2 different forms that we talk about. Next vocabulary word, leading coefficient. This is the number in front of the greatest exponent. So if I were to look at the example I did up here, negative 7x plus 5x squared minus 13 plus 2x cubed, I find the greatest exponent, 3. The leading coefficient would be the number in front of that greatest exponent. So that one would be 2. Like terms is hopefully something you know from junior high. If I wrote out, say, negative 7x plus 5xy minus 3 plus x squared minus 2x. Something like that. If I want to look at like terms, they need to have the same variables raised to the same power. So if I look through here, the only ones that are same variable raised to the same power would be those two. So I could combine those two like terms, can't combine any of the rest. A polynomial is something I've been saying quite a bit now. A polynomial is anything raised to a number power. So, example I do for this one, x cubed versus 3 to the x. This is not a polynomial. Polynomials have to have number exponents. If you have a letter exponent, that is not a polynomial. Last one I want you to know is term. Terms are always separated by addition or subtraction. So if I have, let's do our example from up here. 2x cubed plus 5x squared minus 7x minus 13. This would be called the first term. Then it's separated by addition, so that would be the second term. Separated by subtraction, so that would be the third term. And separated by subtraction, that would be the fourth term. So we would say this polynomial has 4 terms. So, understanding all that vocabulary, pause the video and try to work through 1 through 3 on your own. Once you finish that, you can play and check your answers. Welcome back. So for the number 1, it says identify the terms. The first term is 5a squared. Second term is negative a. Third term is positive 7. The highest power, aka the degree, would be 2. So we would say this polynomial has 3 terms and is a degree 2 polynomial. This one, first term is negative 2x to the 8th. The coefficient is negative 2, which would be the leading coefficient because it's the highest power. The variable is x. The power is 8. Second term is a positive 3x squared. The coefficient is a positive 3, variable is x, and the power is 2. The third term is a negative x, so the coefficient is a negative 1, sneaky 1 right there. Variable is x, and the power is a 1, sneaky 1 in the power right there. Fourth term is a positive 18, which is a constant, not a coefficient technically, so no variables, no powers. Then we have this last one, write it in descending order, should have gotten that, and the degree is 7 because that's the highest exponent. Okay, that's all for vocabulary. In the next couple videos, we'll start to do some examples of adding, subtracting, and multiplying polynomials.